Okay, right now we have this example. Find the mass and the weight of a body if a resultant force of 16 newtons will be hit on an acceleration of 5 meters per second. To make it easier, we separate what the example will give us and what we need. So first, we give us force. How we identify force? We identify force in pounds and in newtons. So we have here 16 newtons. We put 16 newtons in force. Then we put acceleration. That is what it gives us. How do we identify acceleration? Well, in this example, acceleration is very clear. So we identify acceleration in meters per second or in feet per second. Right now we have in meters per second. Then what we need is mass and weight. So we put right over here mass in the question mark and weight. So we put in weight a question mark. We use these symbols to make it easier. So the formula that we're using right now, it will be force over acceleration equal mass, because they ask you mass. So we substitute the letters with what they give us. So we put 16 over 5 meters per second equal mass. We put in a calculator this, and it will give us mass equal 3.2. This is mass. Right now, we move on to weight. The formula of weight is easy. So we have weight equal mass times gravity. Times gravity. So we put weight equal a mass that we know already, that is 3.2. Then we already know that gravity will always be 9.81. So we put 9.81. The answer to that we put in a calculator. So it's 31. Well, we will have right now mass and weight, and we finish.
For this problem, we will have a 5 kilogram block is resting above the table without any friction. It has rope tied that goes over a light pulley without friction, and the mass too that is tied to its other end as it is shown in figure 7.9. First, what should be the mass M2 to impart to the system, and then we need to find what is the tension in the rope for this arrangement. Yes. For this problem, we need to identify what the problem gives us. That is, mass 1 is equal to 5 kilograms. The friction force is equal to 0, and the acceleration is equal to 2 meters per second squared. And we need to find mass 2 and tension. How do we want to find mass 2? We need to look at the figure that they gave us. That is this one. And we need to make this formula, that is all the forces in X equal mass 1 and acceleration. So we are finding tension, that is equal to mass 1 and acceleration. And we plug in the given values that they give us in this part of the equation. That is 5 kilograms and 2 meters per second squared. And the answer will be 10 newtons. That is how we find tension. And for M2, mass 2, we need to make all the forces in Y equal mass 2 times acceleration. So we need to find mass 2, but how we gonna find mass 2? Then we need to put this formula that is weight, because mass 2 is hanging, so there is weight and there is gravity. Weight equal weight 2 minus tension. Weight 2 is equal to mass 2 times gravity minus 10 newtons equal to mass 2 times acceleration. And then we only need to replace what they gave us. That is 9.81 mass 2 minus 2 mass 2 equal to 10. Then and then we pass this to the other side so it can divide. And we need to leave mass 2 alone. Then and the answer will be mass 2 equal to 0.781 kilograms. Bueno, les voy a explicar un problema de Newton second law. Para esto nos dan este problema que nos pide aceleración. ¿Cómo vamos a buscar aceleración? Pues vamos a usar esta fórmula que es fuerza, masa igual a masa por aceleración. Pero como no tenemos aceleración, pasamos la masa a dividir por la fuerza. Y ahora solo hacemos esto. Ahí tenemos que buscar aceleración. El primero sería A igual a 4 sobre 4, porque una fuerza es 4, que sería igual a 1. La B sería bueno, y por último solo vamos a buscar la C, que es 12 sobre 4, que es igual a 4. Y estas son las 3 aceleraciones que nos piden.
Well, right over here we have the final example. We write in here the given mass and what we need to find. They give us acceleration. So acceleration is 2.5 meters per second. What they give us too is tension. So tension is this. Then we need to find mass. So mass, we put the question mark to make it clear. So we move to the body diagram. So we see in right over here that is an elevator that is sustained by a cable. So right over here we have tension. The cable sustains the elevator. So like we said before, we have tension. So we have weight too. We put right over here weight. First we need to make clear that forces that are in y. So we put right over here forces in y. Forces, we need to put forces in y equal mass times acceleration. So this is the formula. Then we can see very clear that we have tension in y. So we put tension. Tension is in positive, but we have weight too, and weight is negative because we can see in that graph that I have that if it goes down, it's negative. So weight is negative equals mass times acceleration. Then we substitute the letters with what weight they give us. So if for this, we write it, then we put negative mass, that is equal to weight, times gravity, because we have mass, we put gravity, equal to mass times acceleration. Then we substitute again. We substitute tension, then equal to acceleration 2.5 meters per second